Today we're going to talk about similar solids. Similar solids are very much like the similar polygons that we talked about earlier in the year. So similar solids are two solids of the same type, so a prism, pyramid, cylinder, cone, that have proportional corresponding linear measures. And scale factor, just like the scale factor we've talked about before, is the common ratio between two solids. So if we take two corresponding lengths within our solids and make a ratio out of them, that's going to be our scale factor. So to determine if solids are similar, we want to check to see if the corresponding linear measures are proportional. So if we take a look at this first example here, we want to write ratios for common lengths. So I'm going to start with my radii. I have 7/4. And then my heights, 16/10. So we want to simplify these ratios to see if we have a common scale factor here. 7/4 can't be simplified. And if we simplify 6/10, we're going to get 8/5. So in this case, no, these solids are not similar because the ratio of corresponding sides are not equal. Therefore, we can't find a scale factor. Pause the video and try the two practice problems on your own. So for part A here, we have first our widths, 12/9. Then we have our lengths, 16/12. And lastly, we have our heights, 4/3 for this rectangular prism, and all of those ratios simplify to 4/3. So yes, these solids are similar with a scale factor of 4/3. For our cones, we first have our radii, 10/5, and then we have our heights, 15/10. Right? These do not simplify to the same ratio, so we cannot say these cones are similar. Therefore, there's no scale factor. To find missing linear measures in similar solids, we want to write a proportion with the corresponding linear measures and solve. So my heights, first I have 12 and 24. And then my side lengths, I have x and 32. So now that I have my proportion set up, I can cross multiply. So first we get 24 times x is 24x, and 12 times 32 is 384. If we divide by 24 on both sides, we get a side length of 16 inches. So this missing side length here is going to be 16 inches. So again, we're just setting up a proportion using those corresponding linear measures or lengths in our prism, and then we're cross multiplying and solving for that missing length. Pause the video and try the two practice problems on your own. So for the first one, we're working with rectangular prisms. We have our widths here, 90/30. Those are corresponding. We also have the 63 and the 21, so you could use those corresponding measures as well. And then we have our height of 90 and our height of x yards. That's what we have to solve for. So those two have to be in our proportion. From here, we can cross multiply. We get 90x equals 2,700. When we divide by 90, we get x equals 30. So the height of the second prism is 30 yards. For part B, we have our heights of our pyramids, 20 and 10, and then we have a side length that we're solving for. So we have x/9. We're going to cross multiply. 10x equals 180. So x equals 18. Our side length of the larger pyramid is 18 inches. Surface areas. So if two similar solids have a scale factor of A/B or A to B, then the ratio of their surface areas is A over B squared, or A squared over B squared. So this is very similar to the ratio of areas we saw in similar polygons. Same idea here. Ratio of surface areas is the scale factor squared, A squared over B squared. So for the first example, these pyramids are similar. We want to find the surface area of pyramid A. So first we have to start off by finding our scale factor. So in this case, we have our heights 6 and 10. So 6 over 10 simplifies to 3 over 5. So our scale factor is 3/5. Next step, we want to find the ratio of surface areas. So to do that, we have to take our 3/5 and square it. So we get 9 over 25. 3 squared is 9, 5 squared is 25. Our last step, we're going to set up a proportion and solve. So in our proportion, because we're solving for a missing surface area, we're going to use the ratio of surface areas. So we have 9 over 25. We know the surface area of the larger pyramid, so that 600 feet is going to go on the bottom next to the 25, because that's our larger number in our ratio of surface areas. And the smaller surface area is going to go on top, our x. That's what we're solving for. So here again, we're just going to cross multiply and solve for that missing surface area. We have 25x equals 9 times 600 is 5,400. And then if we divide by 25, we're going to get a surface area of 216 feet squared. That's going to be our final answer here. So step 1, find that scale factor, which is the ratio of corresponding lengths. Step 2, find that ratio of surface areas. Step 3, set up your proportion and solve. Pause the video and try the 2 practice examples on your own. So for the first one here, the first thing we did, we found our scale factor, 8 over 5. That can't be simplified, so that's our scale factor. Next, we had to find our ratio of surface areas. To do that, we square the scale factor, so we get 64 over 25. So step 1, scale factor. Step 2, ratio of surface areas. And then step 3, we set up our proportion and solve. So our ratio of surface areas goes in our proportion. We were given the surface area of the larger prism here, so that goes on top next to the 64, and then x is on the bottom. We cross multiply and we get x equals 237.5. So our final surface area for the red prism is 237.5 meters squared. For our cylinders, again, step 1 was to find our scale factor, 5 over 4. Next, we had to find our ratio of surface areas by squaring the scale factor, so we get 25 over 16. Next, they gave us the surface area of the smaller. So when we set up our proportion, we're going to use our ratio of surface areas. And then our 110 centimeters squared is going to go on the bottom next to our 16. X goes on the top. We're finding the larger surface area here. We're going to cross multiply and solve for x. So the surface area of the larger is going to be 171.9 centimeters squared. Lastly, we have volumes of similar solids. So if 2 similar solids have a scale factor of A over B, or A to B, then the ratio of their volumes is A over B cubed. So we have A cubed over B cubed. So I like to remember this, right? when we use volume, the units for volume is cubed. So the ratio of their volumes is the scale factor cubed. That's just a quick way to remember that there. So looking at the example, the cylinders are similar. What is the volume of the red cylinder? So again, first step is always to find the scale factor. So in this case, we have a radius of 10 and 12. 10 over 12 simplifies to 5 over 6. So that is our scale factor. Second step, we want to find the ratio of volumes. Right, so to find our ratio of volumes, we want to take our scale factor and cube it. So 5 cubed is 125. And 6 cubed is 216. So here we have our ratio of volumes. Then from there, we can set up our proportion and solve. Step 3 is set up proportion and solve. So of course, because we're solving for a missing volume, we're going to use that ratio of volumes in our proportion. So we have the 125 over 216. We're given the volume of the smaller cylinder, so that's going to go on top next to the 125, 7,850 over x. We're solving for the larger volume here. So from here, we just cross multiply. We get 125x equals 216 times 7,850 is 1,695,600. And if we divide by 125 on both sides, we get a volume of about 13,564.8. So the volume of the larger 13,564.8 feet cubed. That'll be our final answer there. So again, always find the scale factor first. Because we're solving for missing volume, we want to find the ratio of volumes here. To do that, we cube the scale factor, and then from there we set up our proportion and solve. Pause the video and try the three examples on your own. So for the first one, we have two similar cones. We're solving for the missing volume of the smaller cone. Step 1 is to find our scale factor. We have 5 and 12 for our heights. After that, we have to find our ratio of volumes by cubing the scale factor. And then from there, we can set up our proportion and solve. When we cross multiply, we get 20.8 centimeters cubed for the volume of the smaller cone. In part B, we have two square pyramids. First step is to find our scale factor. Again, we have side lengths of 3 and 4 for our base. So that's our scale factor. To find the ratio of volumes, we have to cube the scale factor. We get 27 over 64. And then from there, we set up our proportion and solve. The volume of the larger is 21.3 inches cubed. Last one, we have to work backwards a little bit. They tell us the volume of the larger pyramid is 1,000 centimeters cubed, and the volume of the smaller pyramid is 216 centimeters cubed. And they want us to find the scale factor. So what they give us is the ratio of volumes, because they give us our two volumes. So we have to work backwards to find our scale factor. So the opposite of cubing something is taking the cubed root. So we're going to take the cubed root of 1,000 over 216. The cubed root of 1,000 is 5, and the cubed root of 216 is 3. So our scale factor is 5/3.